Welcome to live stream number 151. Today we're going to talk about understanding joints, and then we're going to talk about this called 80-20 rails. This is a request from a bunch of you guys who want to see how you handle those things. So let me show you what I'm talking about. So here is what is called a 80-20 rail. These are used, I think these are used a lot if you're building kind of different things. I know people have used them to model up, making their own CNC machines. If you're doing any, you guys in the comments area, throw it what you have used all these rails for. They're kind of interesting. So it's Monday. It is April 30th, 2018, and we're going to get into joints, and we're going to get into these. We're going to split this up into 2 days. So today, we're going to talk about how you can go and get these rails into your model. We're going to talk about joining them together, and we are going to talk about, how you can modify them and things like that, best practices. And then, because I know somebody's going to say, didn't really have the one I wanted. Tomorrow we're gonna get into actually how I would sketch one of these up, because if you're looking at them, there's quite a bit going on with some of these. So that is the plan for today. So let's talk about these 80-20 rails. This was one that's just brought in. Let me just get rid of that for a second. Gone. I like to start with a blank screen. We don't want to do all this, cooking show where they just pull out finished stuff in the oven if we don't have to. All right, so let's get into this. How do you get these models? One place to get them is if you go up and you click the insert button and you go down to the McMaster. You can actually search for it in here in the find menu. So if I search in 80-20, that's what these type of rails are called. I like to make the window here a little bit bigger because McMaster has all different kinds of good information in it. And you will actually see that they both have inches metric in here. There's all different kinds of shape. And that's a little bit what we're going to talk about tomorrow. We're going to model one of these up where we just have a drawing of it, so like a 2D picture kind of style. So if you go in and you click on the picture here, you will kind of filter down if you haven't used McMaster before, and you can select your different types in here. I'm just going to select, doesn't really matter what I select. I'm going to select the part number, whatever you want here, and when you do that, you get the product detail, and you will see that it has this little CAD symbol next to it. And that means that there actually is a CAD file for us to download. Makes life easier. Now, in here, when you click on that little detail, we're going to do this a couple of times. Actually, in here, they show different drawings of the different styles. So here is actually the different links. If you click on one of these, so left click, then that's actually when you get to the point where, boom, 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 some of them, so see the fall, the information in 3D model is reference only a detail. So this one here is done at 4 inches. I think that the 2-inch, so this is just about the drawing. Hang on, now I just messed this up. Drop down into the McMaster. This is what I love about these lives. 18-20. All right. And this is going here, select that one, product detail, and let's select this one here. So if we scroll down, there you go. You can download, so the smallest one you can download. I clicked on some different ones in there, so some of them have this is what you're looking for down here, where you can actually download it in the different formats. I normally select the step file in here. Now notice that because we're going to talk about joints and assemblies and all kinds of things, notice that right now inside of Fusion, if you're looking over on the picture over here, I'm just going to check. Can you guys see my mouse? Oh, that might be a setting I gotta adjust in my software here. Hang on just 1 second. This might be on my fault, people. Because I was moving things around. There we go. Now, I think you can see my cursor. Okay. Whew. All this new equipment that I'm playing around with, that is always good. All right, sorry about that. Now you can see my cursor. That's a little bit easier. So over here to the right over here, to the left over here. Notice that right now we have it's a part document right now, right? I just opened up this file, completely dry. I went into McMaster. Let me do that again because that might have been a little confusing. So click on Insert, click on McMaster, and search 1820. And I clicked on the solid there. We clicked on this one here, product detail, and then down we could select the smallest one, and then we can save it as a 3D. Now, so notice how we have the part documents right here, but as soon as I save this, it's gonna bring this in to Fusion, but it's gonna come in as a component itself. So this is actually gonna be an assembly. So let me save this. And you will now see that the icon up here changed to be an assembly. So we now have a component here. I'm gonna do a couple of things through today's live stream. So you're gonna see a couple of different things. But this is one way to do it. The rail gets brought in here. The 1820 gets brought in here. I'm just gonna hit OK. And you will now see we have a rail in here. Now, one thing you can do is to make this a little bit easier, because we're going to bring a couple of more of these rails in. I'm a little bit afraid of everything's going to be gray on gray. If you go out to Inspect and you go down here and you click Component Color Cycling Toggle, then you actually get a specific sign color to each component. You can't control what color to what, but this will give this this color here. If we make a new component, a different component would give a different color, as you can just see in a second. I think it's just going to be a little bit easier for everybody to see. Okay, so I brought in a rail from McMaster. This is all great. So there's a couple of things I want to show you. One is that we can, of course, copy this rail. So if we want a second one in there, we don't have to go back out to McMaster and bring another one in. Now we have one in here. So what you could do was you could click on this component over here, and you could either right click and do a copy, or you can use the Windows command. So I can do copy, and then Control V would paste. And when we do that, you will see to the left we get two components, and we get a move thing here, because if I drag this handle out, you will see it just placed the copy right on top of it. We hit OK to that, and now we actually have two components. Ta-da! That's how we could bring in more rails. Now, what happens though many times when you're doing this kind of stuff is that you want to modify one rail from the other, and right now it's a copy. And what I mean by that is, if I go down and activate our copy here, for example, and I hit Q for press pull, and I select this face here and said I wanted to make this shorter, you will see that our original one follows, because they are copies of one another. The software is literally just say these two are identical. One's going to follow the other, and that can actually be super cool in many times, but other times it's not so super cool. So how can we eliminate that? Well, let me delete the copy we created. Just highlight it over here and hit delete. Go back to the one we brought in. What you can do is you can right click and you can say copy, and then go up and click on the top selection up here. Okay? Right click on that and you can select paste new. So there's a paste and then there's a paste new, but you gotta right click on the top assembly component up here, paste new, and now you would like to see, if you look over on the tree, we still only have one on the screen, but you see that we cut two different colors. We got the light blue and we got now a green. And if I drag this over here and hit OK, you will see that now we got two different colors. If I go over and click on the top eyeball up here, we got two different colors now on the screen. And that means that these two are now independent of one another because we did the paste new. So if I go down here now and hit Q for press pull, and I select this face here, you will now see that it is only one of them they're moved. Right now they are separate in here. So that's a neat little trick if you're trying to build things up like this, is to use this. So we've done that, and now we got to start talking about a little bit about joints, and this. So these 80/20s, I have been asked for a while to do a live stream on these. How do you handle these? Where do you get them, and all that stuff? And one of the things that we run into is then, okay, so you find them, you draw them up, but how do you now use the joint to put them together? And especially if you're coming from another type of software, this can get a little, this is different in Fusion than it, for example, is in Inventor or in SolidWorks. Let me show you what I'm talking about. So if you were using Inventor or some other CAD package, and we now wanted this this rail here, 1820, I don't know if you call them rails or 1820, whatever you call them. If I wanted to make this or join this so it was sitting vertically at the end of this, the way you would normally do this, you would actually do a bunch of clicks. So when we're doing a mate or a joint, what we're trying to do is we're removing degrees of freedom. And there's 6 degrees of freedom. And I know this is maybe a little, if you're brand new to this, if this seems a little overwhelming, don't worry about it. We really just, when I'm saying removing 6 degrees of freedom, we're really just making sure that the thing gets locked down to what we want. So using magnets as an example, for example, Inventor, you would create a reference between, for example, this face and this face. What would make this part go over and be perpendicular with that face? So now they would kind of like be inside of each other. Again, if you're brand new to this whole talk and you're going to use Fusion, just, sit back for a minute. Then when you've done that, you might say, okay, so now I'm going to create a relationship between this face and this face, right? And now they will go up and they will be parallel. And then in the end, you might create a relationship between this face and the bottom of this one down here. Anybody who's using Inventor or SolidWorks, please not in the live stream. Okay, that's how you would do it regularly if you were using those type of software. Well, inside of Fusion, we're using joints, and joints works different. So where Inventor, for example, you are kind of adding each magnet face to lock down the degrees of freedom from 6 down to how many you want. Inside of Fusion, we go the other way around. The first click, we will actually remove all the degree of freedom, and then we let go of the degrees of freedom. Let me show you. So if I would like to create a reference between these two components. First of all, one of them has to be kind of locked down, ground. So we're going to say this one is ground. So I'm going to right click on this component over here, hit ground. That gives it a little thumbtack. So now this one cannot move around, but this component, that can move around. Now let's add that locking joint. So I'm going to go up and select joint, and it's going to ask to capture the position. I'm going to say capture position. I always normally do that. And what we get now is we are getting that little coin that you've probably seen, if you look at my mouse cursor, and that coin is what will lock the two together. So stop thinking about faces, but start thinking about this coin or Pac-Man, or whatever you want to call it. That is what is locking the two faces together. So if I go in here and make it a rule of selecting the component first that is movable, that you want to move, select that one first. And I'm going to go down here, I'm going to place a coin right down on this edge right here. Just going to left click. Okay, so now I'll place the coin there. And then I'm going to go over here on this face, and I'm going to select a second coin right on this edge right here. You see that right there? Okay, and I'm going to left click there. Boom. Just like that, with those two mouse clicks, I have now just added 6 degrees or locked down 6 degrees of freedom to this relationship. So where in Inventor you would click you would make 3 faces to get to this point, I did it just with those 2 clicks. Now if you want to let go of some of the degree of freedom, that is done over here, where you, for example, could select a slide, and then suddenly it would slide in kind of whatever direction you pick in here for this to slide. So I'm going to select rigid. So just with those 2 clicks, that thing is now locked down. I'm going to show this a couple of more times. So I'm going to hit OK to this, and this one is now completely locked in. So 2 clicks, you can remove degrees of freedom. Now let's create another copy to kind of like continue on how we're gonna work with this. So I can go back in here on the first one we created, and I could do another Control-C, Control-V, what will create another copy of the blue one here. And I'm just gonna drag it up somewhere and hit OK. And again, this thing now floats around in space. So what I can do is, to show that joint again, is I can literally just go up to joint and select the one that needs to move. So I'm going to hover over this face here and click till the coin is right on that face. Left click, 1, and then go down and click on where that coin is right on that face. Left click, 2. Now you see that it flipped that around. There's a flip button over here, and we have flipped it back over where it was. But again, 2 clicks and a flip, and this one is locked in. Let's do it one more time with the green one, so we get one of each here. So again, I can select the green one over here in the tree, Control-C, Control-V, and you always get a free move whenever you are doing that. So I'm just move it out of the way. So that one is now floating out there. And again, I can do the same thing. Joint, and I can select wherever that coin is. Now you normally want that coin to touch somewhere. It can't float out in space. You normally want 2 faces. So for example, there and there. And those 2 coins will meet together, and that will lock it down with the 6 degrees of freedom that you normally use to in other type of CAD software. Again, if we wanted to change any kind of relationship, let go of those degrees of freedom, that could be a revolute, it could be a slider, some of these different ones in here. So this here is a way to kind of work through this process. And by the way, everything is at this point still parametric in the way that, you know, if I roll back to that original body down here, and I go in and I hit Q, press pull again, and we selected this face here and we moved it, you know, maybe a little bit closer to where it was before. When I roll back to the end, you will see now that frame is bigger. So everything is still attached, and that's one of the beautiful things about joints. I should also add, just not to, and this is more for, again, like I think at more advanced users, you can actually add joints to sketch geometry too. That's a little, that's pretty cool. Okay, so that was kind of like a way to bring in and join together these different 80-20 parts here in a fairly, I would say, pretty nifty way. But so this is all cool. But I know there's somebody out there who's like, okay, this is pretty cool. This is useful. But I actually want a library of these. You know, I order these in different lengths, and I need to be able to work with, you know, different versions and put them together and modify them. So there's always different ways you can do this. So one way we can do this is let's open up a new document. So we're kind of done with this right now. An empty document here. Let's go in and pick another one. So if you came in late, we're talking about understanding some of these joint functions, and we're talking about these 80-20. So if you missed the beginning, click on Insert, click on McMaster, and select here and type in 80-20. I selected this solid here. Make the window a little bit bigger. Select whatever you want. The product detail with a little cat symbol shows us that there is actually a 3D model. This is great for lazy people like me. You don't have to model it up. Now tomorrow we're going to model this up. But for today we're going to cheat with that. So I'm going to make sure I have it on step file, and we're going to hit save for that. Hit OK, and we kind of brought in, just like we did in the beginning, a new rail. So this would be like how it came from McMaster. Now if I was going to create a kind of like a part library, I might go into my data panel in here and say I want to create a new folder, and I could call this one my 80-20 library. Give that a little name there, right? So now we have that, and we could save this as our, I always used to call my master. That was just kind of like, don't mess with this file. Even, you know, you could type that in. Don't mess with file. This is great if you're working with other colleagues. This is all good because you're like, hey, don't mess with my file. So this is now our master here, and we can save this, right? So now this file is now saved in our library. What means that in the future we got to design a new part. So just open up a third part, and I'm just going to save it here and call that assembly. Right, and that actually probably wouldn't be actually in our library, would it? So the assembly 80. I don't know if I can put in brackets. 80 assembly 20. We're going to save that in our master library. Hit save, and then we can insert. We're still in our library here. So right now, what I actually did was I just saved our assembly out in the root of live stream. And I have now my library in here with this part I just brought in. Now I can right click and I can say insert into current design. And then the file comes in here into our assembly file. Hit OK to place the first one. Now you will see that this one has a little chain on it. It's linked. And the reason this is linked is it's actually looking at that master, don't mess with me. That is, this file somewhat exists inside of this assembly, but is really looking back at this model. What means that if I go ahead and kind of like did what we did before, I can go in here and I can right click and I can create a copy, and I can right click and I can paste it. That's all great, and now we will end up with two copies, just like I did in the beginning. However, if I went in and I hit Q for press pull, you will see I can't select anything on these because they are referenced. That's what this means, these linked files. These are referenced. And somebody might say, well, that's all great. So how do I work with these if I wanted to do that? Well, you can always right click on a file and say break link. And you'll see that it changed color on our screen and we got rid of the link. So now these two are not updated anymore, okay? What means that now if I hit Q, I cannot pick anything on this, but now I could actually do something with this here. Okay, so I hope that that makes sense if you ever are working with reference files like that. But if I was gonna create a master don't mess with me file for an 80/20, let me just delete that one I just changed here. Delete that one. I would actually probably do a little bit of work to this master file to make my life a little bit easier, because you saw in this file that I made it the faces together, those coins together, but I talked about how those coins are meeting each other. But if I was gonna work a lot with this, if I was a pro 80/20 user, I would create a user library like I just did, but then I would use something called joint origins. I would add those to my master file. So joint origins are, like if I just go and click the joint like we saw before, that little coin shows up and you will see that that coin kind of like snaps. If I go down and hit the end file here, it can snap into every single point that appears here. Now, if you ever want to make sure that it stays on the face you have selected, hold down Control or Command on a Mac, and it can now not snap to anything other than that face you hovered over when you clicked on that. What I mean is, if I let go of my Control key right now, I can actually snap into these lines here, to these lines here. But if I hover over this face, hold down Control, as long as I hold down Control, it will only snap to that end face. There was a little goody trick here. But this coin that appears next to my mouse cursor, we can actually, with the joint origin, create these ourselves. So let me show you what I would do if I was going to create a library for this. So select joint origin, and Peter, if you're watching, thank you for the trick you sent me an email about I didn't know about. Gotta give it credit. If I hover over this face right here and I select this place right here, then I get one of those origins or Pac-Mans, whatever you want to call it, right at that face. But I actually don't want it here. I want it parallel with this face, because that's where I want to mate with a join with my screws and everything else in these center rails. So what I can do is, if I grab this arrow and drag it up, so now it's movable, and then select that face, then it will be parallel right to that face. And that was Peter who showed me that. I believe Peter. Thank you. So I would have measured that weird distance probably, and then have typed that in. So I would actually create these types on every area where I know that I many times would have to join things together. And this is going to be a little bit of a work up front, but in the end, it would really, really, really help. I'm probably going to run a little bit over the half an hour today. So what I would do was I would create numerous of these, and you can just, if you have one activated, I can just right click and say repeat joint. I would probably also create one on this face, and then I would move it up till it kind of intersected with the other one. So now I have two sitting right there. You could also right click repeat joint origin. You could also select to say I want one here that's going to be parallel to this face, so sitting out where these two intersect right there. If you know that that's many times where you got to do joints. But let me just, for this case here, let me just throw in one selection of them here. So repeat joint, I'm going to select that area right there and just put that up there, right? So I would go around and create the different ones that I know that I might need at some point. Right click, repeat, just like that. Move up and then select that face. So now I've created 4 of these going all the way around. And I would also do the same thing in the other end. Now, right now, if I go back into our assembly, nothing have changed in here. But as soon as I hit save, and it asks us to do something, so say edit joint origin, you should always get in the habit of typing this in, right? So it creates another version coming over here. That's another live stream. If we go back into our assembly, we now have an update symbol on this part. If I click on that, boom, there these appears. So why did I go through all the trouble of doing this? Well, let me show you. If I go in now and I create a copy, Control C, Control, well, let's do a copy, Control C, Control V. Here we can drag this one out here, hit OK. And by the way, these joint origin will not go away if you change the size. So if I right click and break the link like I did before, so now there's a broken link, you will see if I hit Q, select this face and drag this down, all my joint origin will go along in here. But what I just did was, if I should have created this one down there, would have made it a little bit easier. I'm going to flip it over so I can show you. So what I can now do, if I want to make my life a little bit easier, is when I go and hit joint, instead of trying to select on these faces over here, I can literally just select my coin and then select the other coin, hit the flip key, boom, actually it's going to be there, and then rotate, and now I have just joined those two together with these coins in here versus our first one where we selected the side. So these joint origins are extremely helpful in here to work with. Let me just show you one more thing. If we, for example, decided to download another part for this, so if we go into McMaster, and this should actually go in the library. Let's open up an empty file, insert McMaster 1820, oops, like this. You will see, if you look inside of McMaster, you will see that there's all different kinds of references in here of different components that fits on these that McMaster sells. A tool holder, all different kinds of different things in here. So just be aware if you have all these different ones. Let's select a brace, just like a little corner brace here. Select the product detail, and let's go down here and select this file. So I would bring this bracket in and hit OK, and then I could save that into my library, right? So bracket, and also that's a master bracket, so nobody mess with that. Save that, and of course I could add joint origins to these if I wanted to. But actually in this case here, if I just, oh, I didn't save it in the right place. I saved it probably out in, see, I saved it out I didn't save it in the library, I saved it out here. So right click, move, and then you can double click on the library, hit move, and now it's going to move it over in the library. Okay, now it's in there. So if we go back to our assembly, and I have these joint origins we created on our master, don't mess with me. If I right click and say insert into current design, now this bracket comes in here, and you always get a free move. But it's kind of nice if you ever kind of like want to move them around a little bit, just so you can I like to place them somewhat close to where I in the order that I want them. I just find that a little bit easier. Okay, now what I can do is I can actually go in on this one, and I never grounded this one. Somebody's yelling at me. Ground this one. I can now go into joint and I can select this area right there, and then that coin we bury right down here, and that brace will go in the end there. So I hope that this was useful for this. That you now got a good idea about how I think I would handle the joints, and then these 80-20 brackets that I find them kind of interesting. I think that they're kind of cool how they work. So that was what I was planning on showing today. Tomorrow we're gonna get into sketching. Tomorrow I'm gonna show you how I would draw up one of these 80-20, because I'm sure that McMaster don't have all the different type of million of different 80-20 brackets that is out there. But I hope that this made sense to you, and you kind of like saw a couple of cool tricks. First of all, remember, if you're coming from another type of CAD software, that you normally will kind of like step by step or click by click remove the degrees of freedom. In Fusion, we remove all 6 degrees of freedom first, and then we can let go of them. So those coins are what's going to mate together. And then second of all, if you are working with something like these rails, creating a library out of them is actually pretty good. That was it, friends. I hope you had a good Monday. We'll be back tomorrow, same time. Do me a favor, if you like this, hit the thumbs up. If you don't, hit the thumbs down. I want your feedback. If you haven't already subscribed to the channel, I really would appreciate that. That's kind of like how I can go to my boss and be like, hey, look, people are actually, following along here. And if you hit that little bell icon next to that, you should also get notified every time we're going live. What is, again, tomorrow, 3 p.m. Eastern. That is New York City time. So if you're watching the recording for this, thank you so much for taking the time. If you're in the live stream, I'm going to come in and say hi to everybody. So until tomorrow, have an awesome, awesome day.